Imagine you are in a spaceship with infinite fuel. You slam the throttle forward and you keep it there. You are pushed back into your seat. You are accelerating. 1,000 miles per hour. 1 million. 100 million. According to common sense, if you keep pushing, you should just keep getting faster forever. But you don't. As you approach a specific speed, the universe begins to fight you. The energy from your engine stops making you faster and starts increasing your resistance to acceleration. It's not a mechanical failure. The geometry of space-time itself physically refuses to let you pass. Why? It's not because your engines are weak. It's because the universe itself is lagging. You have hit the processing limit of reality. We usually call this limit the speed of light. But that name is a mistake. Light is just a passenger. The limit itself is something much more fundamental. To understand this, we have to stop thinking of the universe as a physical place and start thinking of it as a computer. Imagine the universe is a massive multiplayer online video game. In any game, the computer has a refresh rate. It's the speed at which the processor can update the position of the player. If you try to teleport from point A to point B instantly, the game engine physically cannot render that change. It has to process the information first. In our reality, the speed limit, which Einstein called c, works exactly the same way. It isn't really about light. It is about the maximum speed at which information can travel through the system. Think of space and time as a stiff fabric. If I wiggle the fabric over here, that wiggle cannot be felt over there instantly. It has to ripple across the material. If we didn't have this speed limit, causality itself would unravel. Gravity would be instantaneous. Every star would shine on every planet simultaneously. Cause and effect would collapse into a single noisy moment. Basically, the speed limit is the processing speed of reality. It's the latency required to keep events in the correct order. Without it, the universe would just be everything happening everywhere all the time. And frankly, I have enough trouble focusing on one thing at a time as it is. Here is the problem. We have a branding issue. We call it the speed of light because light was the first thing we noticed moving that fast. But that's like calling a highway the speed of a Honda Civic just because you saw a Civic driving on it first. Light isn't special. It's just weightless. Photons have no mass. They don't have to pack up for the trip. Because they are carrying zero baggage, they have no choice but to travel at the maximum possible speed that the universe allows. If you had a particle of gravity or a particle of glue that was also massless, it would travel at the exact same speed. We shouldn't call it the speed of light. We should call it the speed of causality. It is the speed at which one thing in the universe is allowed to affect another thing. This isn't just abstract physics, it's local. Every GPS signal, every phone call, every neuron firing in your brain right now is leaning on this limit. You are thinking at the speed of causality. So if light can hit this limit, why can't you? The problem is that you exist, you have mass, and the universe charges a very high tax on mass. As you approach the speed of causality, the math of special relativity kicks in. Now, physicists today prefer to say your energy increases without bound, rather than that your mass literally increases. But the effect on your engines is the same. At 99% the speed of light, you aren't just fast, you are incredibly heavy in terms of energy. To push that last 1%, you would need more energy, which adds more resistance, which means you need more energy. To reach 100% of the speed of light, you would need infinite energy. Since the universe does not contain infinite energy, you can never quite reach that limit. But this raises a question that used to keep me up at night. Why this speed? Why is the limit 299.8 million meters per second? Why not instant? Why not 50 miles per hour? It turns out the number isn't arbitrary. It's baked into the vacuum of space itself. Decades before Einstein, James Clerk Maxwell realized that empty space isn't truly empty. It has physical properties. Specifically, it resists electrical fields and magnetic fields. We call these properties permittivity and permeability. Think of them like the density of water in a pool. The thicker the water, the harder it is to move through. The vacuum of space has a specific thickness for electromagnetic waves. When you calculate how fast a wave can move through that resistance, you get the speed of light. The speed of light is literally determined by how hard it is to magnetize the vacuum of space. If space were easier to magnetize, light would go faster. If it were harder, light would go slower. What if the speed limit were slower? If c were significantly lower, the universe would look radically different. Events would desynchronize in ways we're not built to handle. Cause and effect would drift apart. You might see events long before the information explaining them could even reach you. But it gets worse. The speed of light, c, appears in the equation E equals mc squared. If c drops, the amount of energy you get from mass drops. Stars might not have enough energy to ignite. Atoms wouldn't hold together. Chemistry wouldn't work. The universe wouldn't just feel slow, it would fail to function. A slower speed of causality wouldn't just delay information. It would unravel the mechanisms that make matter stable in the first place. There is, however, one loophole, one way to beat the speed limit. You just have to stop moving. The rule says that nothing in space can move faster than light. It says nothing about space itself. The road is allowed to stretch faster than the car can drive. Right now, the regions beyond our cosmic horizon are moving away from us faster than the speed of light. They aren't breaking the rules because they aren't moving through space. The space between us and them is expanding. This leads to one of the strangest facts in cosmology. The universe is about 13.8 billion years old, but the most distant galaxies we can observe today are over 46 billion light years away. Now, that sounds impossible. How can something be farther away than light has had time to travel? The answer is that the light did reach us, but the space it traveled through kept stretching the entire time it was on the way. The galaxy didn't outrun the light. The road itself kept getting longer. In other words, the universe didn't violate the speed limit. It changed the map while the signal was already in transit. This expansion creates a cosmic horizon. Galaxies that are crossing that line right now are gone forever. Even if we sent a signal at the speed of light today, it would never catch up to them. They have effectively disconnected from our server. They're in a part of the map that will never render for us again. The first time I really understood this, it genuinely messed with my head. It feels claustrophobic to know we are trapped in a bubble of causality. It's easy to feel resentment of that limit. It traps us in our solar system. It makes interstellar travel nearly impossible. But over time, I've come to find it strangely comforting. The speed limit is the only thing protecting us from chaos. If you could travel faster than information, you could outrun cause and effect. You could reply to a message before it was sent. You could return to the Earth before you left. The universe isn't lagging because it's broken. It has a speed limit to prevent the timeline from crashing. It means that reality has a structure. It has rules. And if we can't leave the game, at least we know the engine is working. If this kind of question keeps you up at night too, I make more videos like this, about the universe, the mind, and the strange rules holding everything together. Feel free to like and subscribe, but mostly I'm just glad you were here. Thanks for watching, be kind to each other, and take care.